Dear students, आज न्यूमेरिकल प्रॉब्लम्स ऑन वर्क एंड एनर्जी ਦੀ ਕਲਾਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਵਾਗਤ ਹੈ। ਇੱਥੇ ਅਸੀਂ ਵਰਕ ਐਂਡ ਐਨਰਜੀ ਵਿਸ਼ੇ ਨਾਲ ਸੰਬੰਧਿਤ ਕੁਝ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਹੱਲ ਕਰਾਂਗੇ, ਪਰ ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਕੁਝ ਫਾਰਮੂਲਿਆਂ ਨੂੰ ਰਿਵਾਈਜ਼ ਕਰ ਲਈਏ ਜੋ ਕਿ ਪ੍ਰੋਬਲਮਸ ਸੋਲਵ ਕਰਨ ਵਿੱਚ ਸਾਡੀ ਹੈਲਪ ਕਰਨਗੇ। ਚਲੋ ਸਭ ਤੋਂ ਪਹਿਲਾਂ वर्क के टॉपिक नाल शुरू करिए। Work done by constant force F, which displaces a body through a displacement S in the direction of force, is W equal to F into S. Also, work done W is expressed as a dot product of vector F and vector S. If S1 and S2 are the magnitudes of the initial and final displacements of the body at the arbitrary points A and B with respect to the reference point O, then the work done by variable force is W equal to integration of vector F dot vector ds with lower limit S1 and upper limit S2। ਵਿਦਿਆਰਥੀਓ, ਜੇ ਇਹਨਾਂ ਫਾਰਮੂਲਿਆਂ ਨੂੰ ਚੰਗੀ ਤਰ੍ਹਾਂ ਦਿਮਾਗ ਵਿੱਚ ਰੱਖ ਲਿਆ ਜਾਵੇ ਤਾਂ ਸਾਨੂੰ ਅੱਜ ਦੀਆਂ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਸੋਲਵ ਕਰਨੀਆਂ ਸੌਖੀਆਂ ਰਹਿਣਗੀਆਂ। ਆਸ ਹੈ ਤੁਸੀਂ ਇਸ ਗੱਲ ਦਾ ਧਿਆਨ ਰੱਖਿਆ ਹੋਵੇਗਾ। ਲਓ ਅੱਜ ਦੀ ਪਹਿਲੀ ਪ੍ਰੋਬਲਮ ਵੇਖੋ। A body constrained to move along the y-axis of a coordinate system is subjected to a constant force vector F equal to 2I cap plus 3J cap plus 5K cap Newton, where I cap, J cap, K cap are unit vectors along the x, y and z axis of the system respectively. What is the work done by this force in moving a body the distance of 10 meter along the y-axis? Here the applied force is vector F equal to 2I cap plus 3J cap plus 5K cap Newton. Since the body moves a distance of 10 meters along the y-axis, therefore the displacement of the body along y-axis is vector S equal to 10J cap meter. Here the vector S can be rewritten as vector S equal to 0I cap plus 10J cap plus 0K cap meter. Now the work done is W equal to vector F dot vector S, which implies W is equal to 2I cap plus 3J cap plus 5K cap dot 0I cap plus 10J cap plus 0K cap. On solving, we get W is equal to 0 plus 30 plus 0, which is equal to 30 joules. Hence, the work done in moving the body is 30 joules. आओ एक होर प्रॉब्लम ਨੂੰ सॉल्व ਕਰਨ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰੀਏ। A uniform chain of length 5 meter is kept on a roof such that a length of 4 meter hangs freely from the edge of the roof. The total mass of the chain is 10 kilogram. What is the work done in pulling the entire chain on the roof, given that the value of acceleration due to gravity g is equal to 10 meter per second square? Here we have mass of the chain m equal to 10 kilogram. The total length of the chain LT is equal to 5 meter and the length of the chain hanging from the roof LH is equal to 4 meter. Therefore, mass of the hanging part of the chain m dash is equal to 10 by 5 into 4, which is equal to 8 kilogram. To pull the entire chain on the roof, the center of gravity of the hanging part has to be raised to the roof, which lies at the center of the hanging part of the chain. In simpler words, hanging part has to be raised through a distance h equal to 4 by 2, which is equal to 2 meter. Therefore, the work done is W equal to m dash into gh. This implies W is equal to 8 into 10 into 2, which turns out to be equal to 160 joules. Hence, the work done in pulling the entire chain on the roof is 160 joules. चलो ਹੁਣ काइनेटिक एनर्जी नाल रिलेटेड फार्मूले ਨੂੰ ਵੀ ਮੁੜ ਕੇ याद कर ਲਈਏ। ਜੇਕਰ ਇੱਕ m ਮਾਸ ਵਾਲੀ ਬੋਡੀ v ਵੈਲੋਸਿਟੀ ਨਾਲ मूव ਕਰਦੀ ਹੈ ਤਾਂ ਉਸ ਦੀ काइनेटिक एनर्जी ਹੋਵੇਗੀ E equal to half mv square. According to work energy theorem, work done by force acting on a body is equal to the change produced in the kinetic energy of the body. Thus, we have minus Fs equal to half mv square minus half mu square. चलो ਹੁਣ काइनेटिक एनर्जी ਅਤੇ वर्क एनर्जी थ्योरम ਨਾਲ ਸੰਬੰਧਿਤ ਕੁਝ ਪ੍ਰੋਬਲਮਸ ਹੱਲ ਕਰਨ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰੀਏ। A body of mass 25 kg initially at rest is subjected to a force of 50 Newton. What is the kinetic energy acquired by the body at the end of 15 seconds? Here, mass of the body m is equal to 25 kilogram. Force applied F is equal to 50 Newton. Initial velocity of the body u is equal to 0 and the time duration for which the force is applied t is equal to 15 seconds. If a is the acceleration produced, then a is equal to F by m, or it implies that a is equal to 50 by 25 equal to 2 meter per second square. Since the final velocity is given by v as equal to u plus at, the velocity acquired by the body after 15 seconds is v equal to 0 plus 2 into 15, which is equal to 30 meter per second. Since kinetic energy of the body of mass m and velocity v is E equal to half mv square, so we can write E is equal to 1 by 2 into 25 into square of 30, which is equal to 12.5 into 900. Multiplying this, we get the kinetic energy of the body after 15 seconds as E equal to 11,250 joules, which is also equal to 11.25 kilojoules. ਹੁਣ एक ਹੋਰ प्रॉब्लम ਨੂੰ हल करके देखते हैं। A bullet of mass 25 gram strikes a target with a velocity of 200 meters per second and brought to rest after piercing 20 centimeter into it. Calculate the average force of resistance offered by the target. Let F be the average resistance offered by the target. Then, according to work energy theorem, minus Fs is equal to half mv square minus half mu square. Here, the distance covered by the bullet after piercing S is equal to 20 centimeter, which is equal to 0.2 meter. Mass of the bullet M is equal to 25 gram, which is equal to 0.025 kilogram. Initial speed of the bullet U is equal to 200 meter per second, and the final velocity of the bullet V is equal to 0. On substituting the corresponding values of S, M, V and U in the given equation, we get minus F into 0.02 is equal to 1 by 2 into 0.025 into 0 minus 1 by 2 into 0.025 into square of 200, or F into 0.02 is equal to 0.025 into 20,000. After multiplying and dividing, we get the average force of resistance offered by the target as F equal to 0.025 into 20,000 by 0.02, which comes out to be equal to 25,000 Newton. आज ਅਸੀਂ ਥੋੜੇ ਸਮੇਂ ਵਿੱਚ ਹੀ ਵੱਧ ਤੋਂ ਵੱਧ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰਨ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰਾਂਗੇ। ਜਿੰਨੀ ਪ੍ਰੈਕਟਿਸ ਕੀਤੀ ਜਾ ਸਕੇ ਉਨਾ ਹੀ ਚੰਗਾ ਹੋਵੇਗਾ। ਆਓ ਇੱਕ ਹੋਰ ਪ੍ਰੋਬਲਮ ਨੂੰ ਵੇਖੀਏ। A body of mass 50 kg initially at rest is moved by a horizontal force of 100 Newton on a smooth frictionless table. Calculate the work done by the force in 20 seconds and show that this is equal to the change in kinetic energy of the body. Here, mass of the body M is equal to 50 kilograms. Force applied on it F is equal to 100 newtons. U equal to 0 is the initial velocity of the body, and T equal to 20 seconds is the time duration for which the force is applied. Now, the acceleration produced A equal to F by M, which is equal to 100 by 50, which is obviously equal to 2 meter per second square. The distance travelled by the body with the initial speed u having acceleration a in time t is given by the equation s equal to ut plus half at square. Thus, the distance covered by the body in 20 seconds s is equal to 0 into 20 plus 1 by 2 into 2 into 20 square, which is calculated to be 400 meter. If F and S are the force applied and the distance covered respectively, then the work done is given as W equal to F into S, or W is equal to 100 into 400, which is equal to 40,000 joule, also equal to 40 kilojoules. Since final velocity is expressed by V equal to U plus A into T, the velocity acquired by the body after 20 seconds V is equal to 0 plus 2 into 20, which is equal to 40 meter per second. Since change in kinetic energy can be written as delta E is equal to half mv square minus half mu square, or delta E is equal to 1 by 2 into 50 into 40 square minus 1 by 2 into 50 into 0, which on calculation gives 25 into 1600. On multiplication, we get the change in kinetic energy of the body as delta E equal to 40,000 joules or 40 kilojoules. Hence, the work done by the force in 20 seconds is equal to the change in kinetic energy of the body. And now, let's try to work out another problem of a slightly different nature. A bullet of mass 250 gram dropped by a fighter plane strikes a target with a velocity of 600 meter per second. After passing through a 25 centimeter thick concrete wall, its velocity decreases to 50 meter per second. Calculate the average force of resistance offered by the target. ਕੀ ਤੁਸੀਂ ਇਸ ਪ੍ਰੋਬਲਮ ਨੂੰ ਆਪ ਹੱਲ ਕਰ ਸਕਦੇ ਹੋ ਜਾਂ ਮਦਦ ਦੀ ਲੋੜ ਹੈ? ਚਲੋ ਮੈਂ ਇਸ ਨੂੰ ਹੱਲ ਕਰਦੀ ਹਾਂ, ਤੁਸੀਂ ਨਾਲੋਂ ਨਾਲ ਆਪਣੇ ਸੋਚੇ ਹੱਲ ਨੂੰ ਕ੍ਰਾਸ ਚੈੱਕ ਕਰਦੇ ਰਹੋ। Here S is equal to 25 centimeter or 0.25 meter is the distance covered by the bullet after piercing. M equal to 250 gram or 0.250 kilogram is the mass of the bullet. U is equal to 600 meter per second is the initial speed of the bullet and V equal to 50 meter per second is the final velocity of the bullet. Let F be the average resistance offered by the target. Then, according to work energy theorem, work done against a resistance offered by the target is equal to decrease in the kinetic energy of the bullet. Thus, we have Fs equal to half mu square minus half mv square. On substituting the given values of S, m, v and u in this equation, we can write F into 0.25 equal to 1 by 2 into 0.250 into 600 square minus 1 by 2 into 0.250 into square of 50. Dividing both sides by 0.25, we have F is equal to 0.5 into 3,60,000 minus 0.5 into 2,500. Simplifying this calculation, we have the average force of resistance offered by the target as F equal to 1,80,000 minus 1,250, which is equal to 1,78,750 Newton. Hence, the average force of resistance offered by the target is 1,78,750 Newton. ਹੁਣ ਕੁਝ ਕੰਜ਼ਰਵੇਟਿਵ ਫੋਰਸਿਸ ਅਤੇ ਨਾਨ ਕੰਜ਼ਰਵੇਟਿਵ ਫੋਰਸਿਸ ਨਾਲ ਸੰਬੰਧਿਤ ਫਾਰਮੂਲੇ ਵੀ ਵੇਖ ਲਈਏ। ਕੰਜ਼ਰਵੇਟਿਵ ਅਤੇ ਨਾਨ ਕੰਜ਼ਰਵੇਟਿਵ ਫੋਰਸਿਸ ਹੁੰਦੀਆਂ ਕੀ ਹਨ, ਇਹ ਤਾਂ ਤੁਹਾਨੂੰ ਯਾਦ ਹੀ ਹੋਣਾ ਹੈ। ਬਸ ਨਿਊਮੈਰੀਕਲ ਕੁਐਸਚਨਸ ਸੋਲਵ ਕਰਨ ਲਈ ਫਾਰਮੂਲੇ ਇੱਕ ਵਾਰੀ ਮੁੜ ਕੇ ਦੇਖਣੇ ਜ਼ਰੂਰੀ ਹਨ। The work done in moving the mass m from the point A to B along the path AB is given by WAB equal to definite integration of vector f dot vector dr over the limit A to B. Also, the work done in moving the mass m from the point A to B along the path AB is given by WAB as equal to Gm into small m into 1 by Ra minus 1 by Rb. A force is said to be conservative if the work done by the force in moving a particle along a closed path is 0. Thus, the line integral of vector f dot vector dr along a closed curve joining A to B is equal to 0. Conservative forces ਅਤੇ non-conservative forces ਦੇ ਕੁਝ numerical problems ਹੁਣ ਅਸੀਂ ਹੱਲ ਕਰਾਂਗੇ। Deep in the forest, a leaf weighing 15 gram falls from a tree and drops straight to the ground. If its initial height was 25 meter and its speed on landing was 1.5 meter per second, how much non-conservative force was done on the leaf? The value of acceleration due to gravity at a place is g equal to 9.8 meter per second square. Here m, the mass of the leaf, is equal to 15 gram or equal to 0.015 kilogram. H, the height from which the leaf started falling, is equal to 25 meter. V, the velocity with which the leaf landed on the ground, is equal to 1.5 meter per second, and G, the acceleration due to gravity, is equal to 9.8 meter per second square. Here, for finding the net non-conservative work done on the leaf, first we have to find the initial mechanical energy EI and the final mechanical energy EF. After finding these energies, we have to find the net non-conservative work done on the leaf by using the formula non-conservative work WNC equal to delta E equal to EF minus EI. Since initial mechanical energy EI is equal to UI plus KI and the final mechanical energy EF is equal to UF plus KF, where UI, KI, UF and KF are initial potential energy, initial kinetic energy, final potential energy and final kinetic energy respectively. Also, the initial potential energy UI is equal to m into g into hi being the initial height of the leaf. Now, substituting the values of m, g and hi in the equation for initial potential energy, we get ui as equal to 0.015 into 9.8 into 25, which is calculated out as equal to 3.675 joules. Similarly, final potential energy UF is equal to 0.015 into 9.8 into 0, that is equal to 0. Now, initial kinetic energy Ki is equal to 1 by 2 into m into Vi square. Then, substituting the suitable values of m and Vi in this equation, we get Ki equal to 1 by 2 into 0.015 into 0, which is clearly equal to 0. Similarly, final kinetic energy Kf is equal to 1 by 2 into 0.015 into 1.5, which is equal to 0.01125 joules. Finally, substituting the calculated values of Ui, Ki, Uf and Kf in the equation for Ei and Ef, we get Ei as equal to 3.675 plus 0 equal to 3.675 joules, and Ef is equal to 0 plus 0.01125, that is equal to 0.01125 joules. Substituting these values of EI and EF in the equation for non-conservative work done, we get WNC as equal to 0.01125 minus 3.675, which is equal to minus 3.66375 joules. Hence, the net non-conservative work done on the leaf is minus 3.66375 joules. आओ हुन gravitational potential energy नाल संबंधित formula भी देखो. If a body has moved from A to B through a height h, then work done W is equal to force into distance, which is equal to mgh, known as gravitational potential energy at point B. आओ हुन एक question potential energy ते भी solve करिए. So, तुहाडे लई एक होर question है. How high must a body be lifted to gain an amount of potential energy equal to the kinetic energy it has when moving at speed of 10 meter per second? The value of acceleration due to gravity at this place is g equal to 9.8 meter per second square. Here, the velocity of the body v is equal to 10 meter per second and acceleration due to gravity at this place is g equal to 9.8 meter per second square. If m is the mass of the body, then kinetic energy of the body is T equal to half mv square, or T is equal to 1 by 2 into m into square of 10, which is equal to 50 m. Suppose that the body will acquire potential energy equal to kinetic energy when lifted to a height h. Then mgh is equal to 50 m. On solving for h, we get h equal to 50 by g, which is equal to 50 upon 9.8, which is found equal to 5.1 meter. Hence, the body must be lifted to 5.1 meter to achieve the desired condition. चलो इसे टॉपिक ते एक होर प्रॉब्लम हल करिए. A spherical ball of mass 2 kg is stationary at the top of a hill of height 3000 meter. It rolls down a smooth surface to the ground, then climbs up another hill of height 1500 meter and finally rolls down to a horizontal base at a height of 1000 meter above the ground. Find the velocity possessed by the ball at its final position. Given that the value of acceleration due to gravity is g equal to 10 meter per second square. Here, mass of the ball m is equal to 2 kilogram. Initial height of the ball h1 is equal to 3000 meter. The final height of the ball h2 is equal to 1000 meter and the initial velocity of the ball u is equal to 0. Let v be the velocity acquired by the ball on attaining the height h2. Now, according to the law of conservation of energy, mgh1 plus half mu square is equal to mgh2 plus half mv square. Since u is equal to 0, implying that mgh1 is equal to mgh2 plus half mv square, or v is equal to under root 2g into h1 minus h2. Thus, on substituting the values of g, h1 and h2 in this equation for v, we get v equal to under root of 2 into 10 into 3000 minus 1000, or under root 40,000. This gives v equal to 200 meter per second. Hence, the velocity possessed by the ball at its final position is 200 meter per second. ਮੈਨੂੰ ਪੂਰੀ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦੀ ਕਲਾਸ ਵਿੱਚ ਸੋਲਵ ਕੀਤੀਆਂ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆਈਆਂ ਹੋਣਗੀਆਂ। ਇਹਨਾਂ ਤੇ ਧਿਆਨ ਦੇਣ ਲਈ ਤੁਹਾਡਾ ਧੰਨਵਾਦ। ਗੁੱਡ ਬਾਏ and see you until next time.